Okay, students of 3H, I've got for you the review that we looked at today. You see the different pages which we talked about. Let me just start. So I gave you this homework. What you should do is go. You have to do this homework. You have to do it on separate piece of paper. Hand it in tomorrow. I'll look at it and grade it, and it might affect the grade of the test. Yeah, so definitely put effort into doing this homework. What I've done for you is that really all of these questions that were here have their corresponding one here in the homework. So if you have trouble with the homework, all you have to do is kind of find the corresponding question in this video and then watch that part in the video, and then you should be able to do your homework. I'm also sending you the solutions to the homework. It's going to be on this website which you found this URL at, so that you should also have the solutions there. What else was I going to say about this? Yeah, so again, we didn't get to finish this during the hour. You don't have to finish this. You must finish the homework, however. So the explanation of what I'm doing, you can just watch it. You don't have to finish this. You don't have to finish the worksheet and hand it in tomorrow. You do have to hand this in tomorrow. Okay, so that's I'm going to start again with the whole thing. I'm going to start at the top here, and that's this. We talked about this. These are three triangles. Which triangles are similar to triangle ABC? That's what the question says. Show why. So I discussed this in class, and I said that really we started the chapter with this idea of if triangles are similar, then you can make a ratio table. Well, it turns out that the inverse of that, going the other direction, is also true. So if you can make a ratio table and the ratio holds for all the pairs of sides, that means that the triangles are also similar. So what I've done is I've done ABC here. I've got the 8.5 for this long side, the 4.1 for this side. What is that? It's my telephone. Can't deal with that now. So it's going to be, sorry, lost my train of thought. So I got 8.5 there for this long side, and I've got 18.7 there for that long side. 4 points, so that's here, 8.5 to 18.7. The 4.1 is to the 9.02, and then the 7.1 is to the 15.62. It's right here. Yeah, so and then we're looking at, we've put this in a ratio table, and then we want to say if the ratio holds. So I want to look at what number do I have to multiply 8.5 by to get 18.7, and that number is 2.2. Well, how did I get that number? Well, I took 18.7 divided by 18.5, and I got 2.2. So that means that 2.2 times 18.5 is 18.7. Now, if that's true for all of these, then the ratio holds. Then you have similar triangles. So we do 2.2 times 4.1. What do we get? Well, we get 9.02, so it holds there. Yeah, just use a different color. This is, yeah, so that holds there. And then 7.1 times the 2.2 is 15.6. It holds there as well. So that means that this one, DEF, is similar to ABC. Let's now check this small one. Again, the ratio table, I've got the 8.5, 4.1, and 7.1 of this ABC. Down below, I've written the corresponding sides. I got 4.25 is the long one, 2.05 the short one, 3.51 is the middle one. And now I want to see if the ratio again holds. So really, I'm doing 8.5 divided by 4.25, and it seems like there's a factor of 2 there. So if you do 8.5 divided by 2, I should get 4.25. And if that's true here, it must be true here and here. Otherwise, it's not an enlargement of, or a decrease of that triangle. Yeah, all of the lengths must decrease by a factor of 2. They must all be divided by 2, and if that's the case, then they are similar. 4.1 divided by 2 is 2.05. 7.1 divided by 2 is 3.55. So apparently all of these triangles are similar. So what do I want to see on a test? Is I want to see you make that ratio table, yeah, like this. I want to see you get this multiplier, which in this case is 2. You're multiplying by 2.2. Here you're dividing by 2 to get, yeah, and then you check that the multiplier is the same in each column. And if it's the same in each column, then your conclusion, which you also write down, is this: yes, they are similar. That's how you do that one. Right. Second is this is a given situation. It says calculate FE and BF. So step 1 is kind of analyze this figure here. We've got 2 triangles. We've got 2 right angles in the triangles. We're given that this length is given, this length is given, and that length is given. And we're asked to find FE, which is that, and kind of BF. Alright, so firstly, I don't kind of focus too much on the questions. I just have this idea. I'm going to just solve this whole thing. One thing that you always have to remember is Pythagoras. Pythagoras can often help you. If you see right triangles, always think Pythagoras, and I can immediately see that I can calculate this entire side AE, yeah, with Pythagoras, because I know this one, I know this one, and I know that one, yeah, and that means that I can calculate AC, then subtract AE from it to get this one, and I'll start with that. Yeah, so AC then in my notation is going to be the 3 squared plus the 7 squared, this side squared plus that side squared. Square root of that is 7.62. That means that this entire side is 7.62. Yeah, EC, which is this, is going to be the AC, the 7.62, minus the 3.3, this 3.3. Yeah, and that gives me EC equals to 4.33. I'll put it in. I'll put this 4.33 in here. Yeah. Then I'm going to. I notice that. Yeah, this I know everything about this big triangle. Yeah, I know that. I know one thing about this smaller triangle. That means I should be able to calculate these 2 sides if they are similar. So that's what we try to do now. We try to make these 2 similar. And we do that by finding 2 angles that are, equal. And so I've got angle B, this angle B, equal to FEC. FEC, triangle FEC, is also 90 degrees. That's equal. And both triangles share this point C. So angle C equals C. Therefore, we can conclude that triangle BAC is similar to EFC. EFC. Now when you make this statement, make sure the corresponding points are equal angles. That is important, because once you've done that, you can state this, make this ratio table automatically without any kind of reference to the figure at all. Yeah, it's just mechanical. After you've made this ratio table, you fill in what you know. We know BA to be 3. We know AC to be the 7.62. And BC is 7. F is 4.32. And then we can see that we're able to calculate this and this using that, really. So what do you do for the FC? Yes, so we're doing this part first. It's going to be FC times 7. That's what we see here. We see the 7.62 times 4.32 here. FC calculated this way and FE is calculated basically in the same way. Press pause at any time to reflect on this a bit longer, or rewind to look at it again. I'm moving on to the next one, is the parallelogram. Yeah, first analyze. Yeah, so read the question. I changed this. It said calculate DQ. You're not able to calculate DQ because you're missing too much information. So I made it calculate BP. Yeah, BP is this one down here. So first analyze, and part of the analysis in the start question, I didn't have this. Yeah, part of the analysis is to fill in the numbers that you know. Yeah, so this is 7.3. This part of the parallelogram is 1.2 plus 3.4, so this is going to be 4.6. So we know quite a bit. And let's see, if I look at this triangle, yeah, then I see that it's similar to this triangle. Why? Because these two sides are parallel. I've got this line crossing. That means that this is a Z angle, so this angle P must be equal to D. I've got that here, D equals P. And the C must be equal to the B. C must be equal to the B. Therefore, I can make this similarity statement. I draw up the ratio table like so. I then calculate BP like so by cross multiplying, yeah, and saying BP equals, and then yeah, that's the answer I get. And you see also why we can't calculate DQ, because yeah, both of them are unknown. So there's no, if you cross multiply, you'll get two unknowns. It doesn't work. Okay, next one is the cross product. Important to cross product is that yeah, one of these will be on the test. So earlier today in class I said it won't be, but it will be, so it's important to do this as well. Let's see. For this first one, yeah, you cross multiply. We've done this now a couple of times. It's 4 times 2.1 is going to be x times 6.2. Divide by the 6.2, you get the answer. B works the same way, it's right here. C works slightly differently. When you cross multiply, yeah, it's 4 times x plus 1. Don't forget to put in a bracket around the x plus 1. It's 4 times the entire number, x plus 1. Yeah, is equal to 2 times 3. So then multiplying out to 4 is 4x plus 4, and it continues on like that. Yes. Equations, solving equations. I'm not going to explain the balance method again. This is how you do it. This is an example. You can just yeah, look at it there. Pause if you need to. I then do intersect. Now, this one I will explain some details. I had 4 you guys come in today, and you heard me talk about this, so maybe you want to skip this because it's going to be a repeat really of what I already did. Alright, it says calculate the intersection point of the graph of two formulas. Now, I've drawn a bit here on the right. This is not part of the answer. You don't have to do this on the test. In fact, make sure you don't do a drawing. The idea is that you calculate it. Don't try and do it graphically because I'll count it wrong. Yeah, but just to kind of demonstrate what it is we're attempting to do is I have made a drawing. It says calculate the intersection points of two formulas. Well, this is a formula, and when you graph that formula, it's a line. Yeah, any old line. I don't know if this is the one. It's going to be a line, some line. This is another formula, and it's another line. And mostly, when you have two lines, they're either going to be perfectly parallel or they will intersect somewhere. Yeah. So lines in general often or almost always intersect. And when they intersect at a point. And what you're asked to do is calculate that intersection point algebraically. Now, what's true about an intersection point is that the y values of both formulas are the same. Yeah, this is one point, so it's one coordinate. In other words, the y of the one formula equals the y of the other formula. And so this is a y equals, and this is a y equals. So what do? We set these two things equal to each other. And as I said to the girls that came to see me today, yeah, that will be one point. question like this, 3 points worth. So that would be 1 point if you're able to write this, just write this equation. Yeah. And then use the balance method to solve the equation. And if you get an answer that's correct, you get another point. Yeah. Show your steps. Let's say you get this answer wrong. Doesn't matter. I'll use your wrong answer to see if you continue with the last part of the question. Namely, x is 4 is not the final answer. It asks calculate intersection point. So calculate the point and not just the x. So I want to know what the y value is that goes together with this x. So a point is something like, it has two parts. A point is an x and a y. So the x we just said was a 4. The y, how do we get that? Well, we put it in the formula. So we put this x into this formula, or that one, it doesn't matter. So put it into there, and we're going to get 1.2 minus 0.2x, and then replacing is 1.2 minus 0.2 times 4, this 4, yeah. So that's going to be 0.8. 1.2 minus 0.8 is 0.4. So the y value of where they intersect is then 0.4. So the answer is 4, 0.4. And don't believe me, put it in here. Yeah, 4, put in there, got 0.3 times 4 is 1.2. 1.6 minus 1.2 is again 0.4. So it works there as well. Right, I'm continuing with this one. Now, this one is kind of similar. It says consider the functions fx, 3x, 1, and 1. G of x is 2 times, in brackets, half x plus 1. Now, it says the graph of f intersects the x-axis at point A. Now, again, I've drawn something for you here which should not be part of your answer. It's more of a visual aid. And you may want to do this on the test, but you don't have to. I'm not going to look at it, at least. But it's just to say, yeah, the graph of f, and I've kind of made a representation of f. It doesn't matter whether this is the real f, or f goes this, or it does something else. But in general, a line will somewhere cross the x-axis, and it will somewhere cross the y-axis. And it's telling you that this f, you want to look where it crosses the x-axis, and that we're going to call point A. Yeah, that's what it says in the text. So then this is point A, because that's where this is, yeah, the x-axis. And what do we know about every point on the x-axis is that the y-coordinate is 0. Yeah, this is the point, for example, 1, 0. Yeah, this is the point 3, 0. This is the point, what is it? 6, 0. Yeah, the y-coordinate of any point on the x-axis is 0. So that's what you say that you know about point A, that y is equal to 0. Now, if y is equal to 0, and this is a line, we want to set this 3x minus 1 equal to 0. Yeah, because that's what we're calculating. If you're calculating the y that corresponds with a particular x, you put the x into the formula to get the y, and now the y is 0, so we're looking for the x that makes y 0. Yeah, so if 3x minus 1 is 0, then x equals a third. And what do you get when you put 1/3 into 3x minus 1? Well, try this. 3 times a third is 1. 1 minus 1, you get 0. Of course you get 0, because that's the x you set out to find. You set out to find the x, which will make y 0, and that x is 1/3. So the point A is the point 1/3, 0. What to remember about this, if it says intersects the x-axis, that means y equals 0, and that means set the formula equal to 0 and solve for x. And make sure you give the point, don't make this your answer, make that your answer. Yeah, the point 1/3, 0. Second part says, the graph of g intersects the y-axis at point B. So this is g. That means that this is the y-axis, this is point B. And what do we know about any point on the y-axis? Yeah, is that the x is 0. Yeah, this is the point, let's see, 0, 4. This is the point 0, 3. This is the point 0, minus 2. So we know, because it's on the y-axis, that x is 0. So what do you do then? Well, you fill in x is 0 into the formula. Yeah, of g, because it said g crosses the y-axis. We've got g equal y is 2 times 1 half x plus 1. So replace the x with a 0. And what do we get? That y equals 2. So what's the coordinate? Well, x equals 0. You filled in the 0. What's the y? 2. We just calculated that. Done. Part C says, or point C, it says, and the graphs of f and g intersect at point C. Calculate the coordinates of points A, B, and C. So point C is the same exercise as before. It's asking you when two lines meet. Yeah, so it's the repeat question. What do? You set the two formulas equal to each other. You solve for x. Then you get 3 halves. For x is equal to 3 halves. You're not done yet because you need to find out what the corresponding y is. Remember, a point is always two numbers, the x coordinate, the y coordinate. Yeah. So we put the 1.5 back into there. We say 3 times 1.5 is 4.5. Minus 1 is 3.5. So the y is 1. Could I have put it into there? The answer is yes. A half of 1.5 is 0.75. Yeah, 0.75 plus 1 is 1.75. 1.75 times 2 is also 3.5. So you could have put it in the other formula as well. Right. Third, I've got lines. What does the slope mean? Well, y equals ax plus b. This is the slope. This a is the slope. Yeah. So it says calculate the formula k and l. First step, find two good points. Two good points, k here. Second is draw this triangle. I've got 2 down 3 is minus 2/3. So I'm going to, for k, have y is equal to, I should do it a bit longer. A is equal to rise over run. So I've got the minus 3 over 2. So I've got y is equal to minus 3 halves x plus b. Then I take any old point and fill it into the formula. Yeah. So I'm going to take this point, which is 0. It's not 0, 3. It's 3, 0. Yeah. Fill it in, and I'm going to get 0 is equal to minus 3 halves times 0 plus b, and I get something that's not correct. Okay, sorry, I'm confusing myself. It's 3, yeah, so it's x is equal to 3, yeah, and the y is equal to 0. That's what I filled in. So that b is going to end up being 9 halves, or equal to 4.5, which looks about right, as this is 4.5. Lastly, I write down the formula y is equal to minus 3 halves x plus 4.5. Yeah? I'm now going to do L. L, pick two good points. 1 there. Triangle to the right. This is 1. That's 3. So I've got the A equal to rise over run is 1/3. I write y equals 1/3 x plus the b. What's the b? Fill in the point. I would say a 5, 0, but you could also do the other one. You want to do the other one? It's 8, 1, so I'll fill that in. 8, 1, so 1 is going to be 1/3 of 8 plus b. So 1 is going to be equal to 8/3 plus b. 8/3 is equal to, let's see, 2 2/3 plus b. Then I've got b is equal to 1 minus 2 2/3. So that b will be equal to, minus 1 2/3. Is minus 1 2/3. So the formula is y is equal to 1/3 x minus 1 2/3. That's the formula for the L. Yeah. Then thirdly, I've got this question. Now you can skip this part of it. you can also skip that part of it. We scrapped that from the test. So find the formula of the line which goes through the points a 2 minus 1, b 8 1. And if you find this confusing, yeah, because it's not graphical, some people are smart, yeah, you can do it without drawing a graph. Yeah, you can say that the a is equal to the difference in y, so it could be the difference in y, so it's going to be yb of 5 point b minus 5 point a divided by xb minus x point a. So that could be then a minus 1 minus 1 is the difference between this y value and that y value. Then the difference, the x, is 2 minus the 8. And that's going to be minus 2 minus 6 is going to be equal to 1/3. Yeah. Or if you find that confusing, just plot the points. Plot the points. So I've got 2 minus 1, 2 minus 1, and 8 1, 2 4 6 8 1, like that. And then there's going to be a line through that. Yeah. And then we draw the triangle. And the triangle says I go to the right 2 4 6, and I go up 2, the rise over run, yeah, is going to be equal to 2/6 or equal to 1/3. Yeah. You're doing really the same thing, but you need this visual aid, which is no shame. But you'll notice, of course, that this method works for very large numbers, with crazy numbers that you can't really graph or unpractical to graph, whereas the graphing technique only works for kind of nice numbers. On the test, it'll be nice numbers. So you either get this, use that. If you don't, do it this way. It's the longer way. Again, we get y is equal to 1/3 x plus b. I'm going to put in one of these points. I'll do minus 1 2. Minus 1 is equal to 1/3 times 2 plus b, and we get b is equal to minus 1 and 2/3, and I don't know if you noticed, but it's exactly the same one as this one that we had here. So it's going to be y equals 1/3 x minus 1 and 2/3. Okay. So different way of asking the same question. Here I asked the question just giving the 2 points, and here I give you the graph of it. Yeah, but basically it's the same question. You work it the same way. Okay, so that was it. I hope again, you don't have to finish these exercises, but you do have to finish this homework. See you tomorrow. Bye-bye.